Alright, so our first polynomial in months, there is a really good chance that there will be a polynomial on next Friday's test. So make sure to review this quite a bit. I believe question number 2 is a polynomial and question number 3 is a quadratic. So, or one of them's one and one of them's the other. Okay, one quadratic, one polynomial. So let's go ahead and plot this. My recommendation, because we have to get some numbers that go all the way up to 40, I recommend, well, first off, one thing we haven't talked about in a long time is time is usually X. Like you usually have to start a stopwatch before you actually can study what's actually going on. So be careful. We might do this on the test every once in a while or on this worksheet. The X's and the Y's might be out of order. Okay, so X is really going to be time and the height is really going to be Y in this problem. So it's kind of reversed. I would go by ones this way to get all the way up to 13. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to work out. 1, 2, 3, 4, 5. Okay. Then I would go up by 2s to get all the way up to 40. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And start plotting. So this is in seconds, and this is in inches. Okay, so it's backwards, so be careful. 1.540. It's going to be right here. 410. It's going to be here. 4.50 is going to be right here. 6, 7, going by 2, so it's going to be right here. 7, 7 is here. 8, 0, 9, 2, 12, 0, 13, 1. Alright, so this is kind of a little awkward. There's dots all over the place. But read the story. The story says it's a ball bouncing on the ground. Okay, that actually can bring some clarity to why these dots are the way they are. If we follow the dots and we start to connect them, this right here is talking about the ball falling. Okay, the ball is crashing towards the ground. And then here, it appears to hit the ground. And what's going to happen when a ball hits the ground? Is it going to go through the ground or is it going to bounce off the ground? We'll get a bounce. And then we have to hit both of these dots, so it looks like after it bounces, the ball's going to go back to the ground and bounce again, and then it's going to go back up, and then it's going to bounce again. And then eventually the ball is going to keep doing stuff, but we just don't know what it's going to do because it got paused. We don't have enough information to see what's going on afterwards. And so at the moment, it looks like to the right it's going up, but we know balls are going to go back down. However, it got paused, so right now it looks like it's pointing up. And so, what kind of picture did we just draw? It's not a line. It's not a quadratic. It's been a long time since we've actually done a polynomial, because polynomials have all the U-turns, right? So, what do we need to know about polynomials? Here's our crash course into it. The most important thing about polynomials has always been the x-intercepts. Where does it touch the x-axis? Polynomials love the x-intercept. So it appears that the ball first hit the x-axis right here at 4.5. And then the ball hit the x-axis right here at 8. And then the ball hit the x-axis here at 12. And if we go to our table, that was going on right here, here, and here. Also, at each of these locations, they bounced. A ball bounces. That's actually going to be a very important math move for us. Okay, so polynomials, we need all that information. Once you have all that information, go back to line paper to do some extensive calculation. But fortunately for us, for polynomials, it's not going to be as ugly as quadratics because of the x-intercepts. So, here's our example for our ball bouncing. Now, the nice thing about polynomials is this. We write y equals a just like a quadratic, but we don't have to worry about the vertex. What we're going to do now is we're going to say x, and the first x-intercept was 4.5, so I'm going to put minus 4.5, quantity, so x minus 4.5, it's always the opposite. And because it's bouncing, we put a squared. I don't know if you guys remember around winter break we were talking about like multiplicity of 2, multiplicity of 3. Probably have since forgotten it, which is okay. But when it bounces off the x-axis, we need a squared. The next x-intercept was 8, x minus 8. Parentheses, it also bounced, so it also needs a square. If one of these didn't bounce, then you wouldn't put the exponent. And then the last one's x and 12, so x minus 12. It also bounced, so squared. Now, because our picture right now tentatively is pointing up, because to the right it's tentatively pointing up, A is likely going to be positive. If the right arrow points up, A is positive. If the right arrow points down, A has to be negative. All right, so there's all our setup. How do we figure out what the A is? We have to go back and pick a far point just like a quadratic. So, what is the furthest point to the picture so far? At the moment, if we look at this, these are all the x-intercepts. The furthest point from all these x-intercepts turns out to be this one. Even though it is like on the left and it was the first dot, if I look at all 3 x-intercepts, this one is the furthest one away, technically speaking. Okay, so the far point here is going to be that first one, which was 1.5, comma 40. So I'm going to drop that far point into the x's and the y's. So y is going to be 40 equal to A. A should eventually be positive, at least because of the right arrow. And then I'm going to go ahead and take this 1.5 and write it in all 3. So wherever I see an x, I'm going to put a 1.5. 1.5, 1.5, 1.5, and then minus 4.5, minus 8, minus 12. Once you have that in there, you're just going to calculate very carefully. So 1.5 minus 4.5 is negative 3 squared. 1.5 minus 8 is negative 6.5 squared. And 1.5 minus 12 is negative 10.5 squared. Now remember that squared basically means copy and paste it. Just as a side note, reminder, you don't necessarily have to do this, right? You don't necessarily have to write it down, but you have to at least think it. Okay, squaring means copy and pasting. And multiplying all those numbers together is going to give us 41,922.5625. Divide by this crazy parentheses, 41922.5625. That crosses that out. 40 divided by this is going to give us an extremely small number. Now your calculator, a lot of calculators is going to give us one of these E's. That's scientific notation that's been showing up more and more these past recent weeks. Remember, this just means scientific notation. When it's a negative, that means you have to move the decimal 4 times to the left to get the right answer. Okay, if it's a positive, you move the decimal to the right. Negative means make it smaller, positive means make it bigger. So if I move it 4 decimals to the right, or excuse me, to the left, I'm going to get 30954. It is positive, so that's good. The fact that it is positive is great. And now I can write my answer. Y equals, put your A in. And you're going to write the 3 parentheses with the squares. Do not include the far point. Never include the far point in your model. So this is the polynomial model right here. And if we go back and we read the directions, all they wanted us to do was talk about the x-intercepts and find the equation. So this is really the answer for B. And the answer for A was this part that we did earlier, the x-intercepts.